Hi there! This series covers the first 100 Project Euler problems to help you learn how to solve unfamiliar problems. Project Euler presents complex math challenges to be solved with programs running in under a minute. Although they prohibit sharing solutions, the first 100 problems can be shared for instructional purposes. I encourage you to attempt each problem on your own before watching the corresponding video. I am currently learning Python and have been doing so since mid-January. I have no professional experience in the language and have only completed the Python for Programmers course on Execute Program. While I am learning quickly, I don't claim any real expertise. Today, we're looking at the 53rd Project Euler problem. As always, I will link to the problem and my repo in the description. Let's dive in. Problem 53 is combinatoric selections. There are exactly 10 ways of selecting 3 from 5, 1, 2, 3, 1, 2, 4, etc. in combinatorics. I should have looked up how to pronounce that. In combinatorics, we use the notation 5 over 3 equal to 10. In general, n over r equals n factorial over r factorial times n minus r factorial, where r is less than or equal to n factorial is n times n minus 1, etc., times 2 times 0, and 0 factorial equals 1. It is not until n equals 23 that a value exceeds 1 million. 23 over 10 is equal to this long number. How many, not necessarily distinct, values of n over r for, or really this should probably be pronounced like n combined r, for 1 less than or equal to n less than or equal to 100 are greater than 1 million. So it does allow us to kind of cheat here in that it says it's not until 23 that the first one happened, but I'm going to ignore that and just, there's only 100 numbers here. If we were going up even to 1,000, that would be a bigger deal. But I think for terms of this, we're just going to go through everything. Okay, problem 53. Someday I'm going to organize these files a little better. Maybe. But for right now, it's fine. N less than or equal to 100, greater than 1 million. Alright, as always, come in here, start with this, copy that one twice, we can print it out. Let's go ahead and make ourselves a count of 0, and then we're going to say for n in range 1, 101, because we want to do less than or equal to 100. Yep. And then for r in range 1 n plus 1, we are going to calculate in r, and then if greater than 1 million, increase count. Obviously, that's not the correct formula, but I'm just gonna do this if statement first. And then we just print out our count. And really, obviously we need to do this part, but, like, that's all there is to the logic here. And again, we're doing an inner loop here, which means we're going to be exponentially increasing how long it takes to run this. But since we're only looking at 100 numbers, that shouldn't make much difference for this exact program. So I am going to create a method here, and actually it's going to be another inner loop for the factorials, but find factorial, and I'm going to have it take in an x, and then result equals 1, and then for I in range 1 x. Actually, yeah, that works. Now, result equals 1 plus 1. Yeah, I'm gonna say 0, or in range x to 0 minus 1. The 0 is exclusive, so we won't ever get to that. And we're going to say result equals, or rather, let's just do times equals I. And then we return result. And that's the factorial for any integer. So fact n equals find factorial n, fact r equals find factorial of r, and then let's go look at our formula again. So we need n factorial, r factorial, and then minus r factorial. I'm going to just say it like that. So fact n divided by fact r times fact nr. And that'll be how many combinations there are. Double checking the formula. Yep. Okay, and let's see. Go ahead and run that. Okay, we got 4075, ran in basically no time whatsoever, a few hundredths of a second. Oh. Sometimes I do that. Alright, and that is the correct answer. So, this is one of the easiest difficulty rating, and this one honestly deserves it so much. Because once you realize I'll just make Python do the math for me, or whatever language you're using, I'll make the language do the math for me. All you do is you set up the loops. And obviously if we wanted to do up to 1,000, that's going to end up taking a lot longer. Honestly, a little bit curious about how long it'll take. But very, very simple algorithm going on here. Obviously got the correct answer in the first try. This time I didn't even make an error in the coding like I normally do. So, yep. Yeah, see, obviously it's taking much longer. And that's because, again, we have effectively an O of n squared going on here, or really an O of n cubed, because of finding the factorials. So, increasing this even slightly just increases the runtime exponentially. Alright. Give it another few seconds here, and then I'm just going to call it. Yeah. Let's cancel that out. We know we got the correct answer. We got it within the time frame. We got it on the first try, so good job there. And I will catch you in the next one.